Okay, now let's talk about the LDR or photoresistor. Okay, LDR or photoresistor is the sensor that can sense the lighting condition, the environment lighting condition. Okay, it will change the electrical signal according to how much the intensity of the environment illumination, or intensity of the surrounding environment. So in general, the LDR or photoresistor have been used for, I think, if you familiar with some, automatic light, when there's a night, during the night it will turn on, during the sunny day it will turn off. Say that kind of light or lamp is actually, they utilize this sensor in order for them to sense the environment illumination condition. Is it sunny day, is it night, and so on. Okay. Okay, for this one, I take this example again. This example is not uh, using the the Arduino. You can also try this one, but this one, I think they playing around with, if you change the resistor, the sound here, because this is buzzer that we will talk later. They using buzzer to indicate the changing of lighting here. Okay, but let's talk about this one, the operation where you have a photoresistor, you have a battery, you have a motors there. So what happened? So if I run this simulation, okay, then you just click this photoresistor during the simulation process. So that's showing some lighting there, means that this is like during the night day, when the environment is dark, and this is sunny day. So if you increase the intensity of the environment, and the motor will become the speed of the motor is increased. Okay, so of course, if you want to connect this thing with the Arduino, you need to use the analog input. Okay, because now it's analog, it's like your potentiometer. Okay, because the voltage is changing according to the condition of the lighting, the surrounding lighting, or the environment lighting. Okay, how about a temperature sensor? Of course, temperature sensor is to measure the temperature, the environment temperature. So let's go for the Tinkercad. So you just can type the temperatures. This is the temperature sensor, but to know how actually it's work, you can use this one, this example. Okay, if I start do simulation with this circuit, okay, I just click the temperature sensor. So actually it's almost similar with photoresistor. Okay, the photoresistor is the simulation, is the environment, it sense the lighting of the environment, but this one, it send the temperature of the environment. But the process is the setup is almost similar. It's like look like if you want to connect with Arduino, you need to use the analog input, and actually this one is look like the example, the one that we use the potentiometer, because once you change the temperature, the resistance is changing. That's why this pin over here will give some voltage. Actually this voltage is represent this 45 degrees Celsius. Okay, if you reduce it into 18, it's actually represent by 0.679 volt. Okay, so from that actually you can estimate the temperature. So again, like I said, this is the physical changing, this is electrical changing. So that's why a sensor is a device of changing the physical, it sense the physical environment changing, and it convert that changing into electrical signal. So it's almost similar with photoresistor and as well as your potentiometer. The difference is just the what type of physical environment does this sensor sense. For temperature sensor, it sends temperature. For photoresistor, it sends um, it send the lighting of the environment, or the intensity of the environment, the intensity of the lighting. And then for potentiometer, of course, it send the position, the rotational position, because you are tuning the potentiometer. That is also can consider as a physical changing. Okay, how about PIR motion sensor? Okay, PIR motion sensor is used for detecting any motion. Is there any motion that's across this in front of this sensor? It will trigger, or it will send some electrical signal to the to your Arduino. Okay, that is the purpose of motion PIR motion sensor. Okay, you can type PIR. Okay, this is a PIR motion sensor. Okay, again, of course, this one is not the example with Arduino, but you can later explore on how to deploy this thing in Arduino, so it can become your project, or you can become one of your project, one of the module that you can use for your project. Okay, I just run the simulation and click this PIR motion sensor. Okay, assume this is the object that across in front of this sensor. Okay, so you can see the LED is turned on. So you can see that PIR motion sensor is a little bit different from the ultrasonic sensor, because ultrasonic sensor, it sends the obstacle or any object that going in front of that sensor. But for PIR motion sensor, for ultrasonic sensor, it will obtain as well as the distance between that object and the sensor. Okay, that is for ultrasonic sensor. But for PIR motion sensor, it does not send the distance. Okay, anything that cross this area, it will trigger this, or it will turn on this LED, because the sensor itself will give a 5 volt. Okay, so meaning that if you want to connect the PIR motion sensor, you need to connect with the digital input. Okay, you must connect with digital input of your Arduino, because the condition is once there's the object across this field, it will turn on or become 1 or 5 volt. But later, when the object is not moving, or the object is outside the range, it will become 0. So it's also, that means the input of the signal to Arduino is digital signal. 1 is detecting motion, and 0 when there's when there's no motion. Okay, it's different from, or it's in contrast with ultrasonic sensor, because ultrasonic sensor is the input, the output from that sensor is analog signal that represent the distance. So that's why you need to use the analog input port to operate the ultrasonic sensor. Okay, the last one, gas sensor. Okay, for gas sensor, you just can type gas there, but unfortunately for gas sensor, we don't have any example how to operate this sensor. So I just put the sensor in this simulation. I run the simulation. As you can see, still the simulation is working, meaning that you assume this is your gas sensor, and this is the or smoke sensor. Okay, it's the same thing. Smoke sensor or gas sensor is the same thing. Assume this is the gas or the smoke. So in general, when the smoke is close to that sensor, it will trigger the leads there, but I'm not sure which lead that will trigger or turn on. So that's why later you need to explore, you need to find out from the data sheet or from the Googles to find out how to operate this gas sensor. So how to connect these six, there's a 6 lead there with your Arduino, because in general the sensor is like it will provide the digital signal, so you need to use a digital input port in Arduino, because when the smoke is close to the sensor, it will become 1, and when the smoke is far from the sensor, mean there's no smoke, it will become 0. So that is one of the things, if you can you can explore and use it for your project. It's a great thing for you, because now this is like your homework, okay? Because we don't have any example, maybe you can explore by yourself. Okay, that's all for several example of sensor that you can use with your Arduino.